Alright guys, so today we're talking about systems of equations. You've actually solved 2 by 2 systems, well, have supposed to have solved 2 by 2 systems in Algebra 1, but we're going to review it. So, is 2, 1 a solution to the system of equations shown below? No, a system of equation refers to a set of 2 or more equations. So this would be our system of equations right here. We want to know, does 2, 1 work as a solution? Well, 2 is an x, 1 is a y, so what we're going to do is we're just going to plug these in to make sure it works. So we'd plug 2 in for x, 1 for y here, 2 for x here, 1 for y here. That would give us 2 times 2 minus 3 times 1, which does that equal 1? That's the question. We have 4 minus 3, which it looks like it does. On the other side, we have 2 plus 1, which equals 3, and that also does. So in this case, 2, 1 is in fact a solution to this system. What does it mean for a point to be a solution to a system of equations? It means that when plugged in, it makes the system true. And as you can see above, both of those worked out properly. There are 3 ways we're going to learn how to find a solution of systems of equations. The first method is graphically. Okay, it says get the equations into y equals mx plus b form to graph. You can do that, or if you remember your intercept form, or graphing using the intercepts, you could also do that. I prefer getting my equations into slope-intercept form, so that's what I'm going to do. So this first one, I'm going to subtract 3x from both sides. You get negative y is equal to negative 3x plus 4. And then I'm going to divide everything by negative 1. That gives us y is equal to 3x minus 4. So then our first graph, negative 4. Going to go up 3. 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. Again, you only need 2 points to graph a line. I'm going to graph 3 just to make sure I'm being extremely precise here. Okay, and then my next line, I'm going to subtract that x from both sides. That's going to give us negative y is equal to negative x minus 2. Divide everything by negative 1. You get y is equal to x plus 2. So then we're going plus 2 here. X would be up 1, right 1, up 1, right 1. So then I'm going to follow this graph in this direction. And I'm going to follow it down like this. So then our graph is going to look something like this. I realized that my graph below here is not correct. I put it at 5, it's 4. So that's going to move that there. There we go. All right, now we should have the correct solution. So solutions to systems of equations occur at intersection points. So right there we have an intersection. 1, 2, 3, up 1, 2, 3, 4, 5. So this point is positive 3, positive 5. Okay, so then that would be our solution, 3, 5. We write them as points because that's what the solutions to systems of equations are. They're points. It's an x value and a y value. All right, let's take a look at these next graphing scenarios. So these next 2 examples are actually special cases, which you'll see as soon as we put them into slope-intercept form. So for the first one, I want to subtract 3x from both sides, so negative 2y is equal to negative 3x plus 6. Divide everything by negative 2. You get y is equal to 3 halves x minus 3. I'll graph this one, so negative 3, 1, 2, 3 down, and then we're going to go up 3, 1, 2, 3 to the right 2, puts us right here. And again, you only need 2 points to graph, so I'm going to graph there, and come back down and graph this way as well. All right, for the next graph, again, I'm going to subtract 3x from both sides. You get negative 2y is equal to negative 3x plus 2. Divide everything by negative 2. And you get y is equal to 3 halves x minus 1. So we're going to go minus 1. We're going to go up 3, 1, 2, 3 to the right 2. And then we'll graph this line as well. And if you take a look, when you graph this line, Oops, that was a little off. Anyway, once you graph both of those lines, as you can see, because the slopes are the same, these two graphs are parallel. Well, parallel lines are never going to intersect each other. So this is our special case where we get no solution. All right. The next example, we are going to, again, subtract 3x from both sides. So negative 2y is equal to negative 3x plus 6. Divide everything by negative 2. You get y is equal to 3 halves x minus 3. So that's negative 3, 1, 2, 3. Up 3, 1, 2, 3 to the right 2. There we go. Graph this line. Graph it down. And then I'm going to do that same thing with the next equation, except I'm subtracting 6x, so negative 4y is equal to negative 6x plus 12. Divide everything by negative 4. You get y is equal to 3 halves x minus 3. So here's the special case, right? This is the same exact line that we just drew. So why is this a special case? These two equations actually create the same equation. So the answer for this is every single point on this line is going to be a solution. So what is the answer? There are infinitely many answers. So infinitely many solutions is going to be our answer here. Okay? One thing that gets tricky and some people want to say is they want to say all real numbers, but technically we can't say that, right? If we said all real numbers, that would say that 0, 1 is a solution, but if we go to 0, 1, it's not on either of those lines. All right? So we have to say infinitely many solutions here. All right. So next, it says now let's solve the following systems with our graphing calculators. Follow the directions step by step. Watch video number 1 for help. So, when solving with our graphing calculators, I'm actually going to let you guys go through this section on number 4 here. And if you have questions, feel free to ask me, either in class today or in class tomorrow, whichever you prefer. The second method for solving systems of equations is through substitution. So, I'm just going to do this. You can read this section if you would like to, but I'm just going to show you how it's done. So solve the following system by substitution. This is probably the way most people remember how to do it. In order to do this, we first need to solve for a variable. It can be either x or y. I'm going to solve for x. So if we subtract 2y from both sides of that bottom equation, you get x is equal to negative 2y plus 2. All right? What we're going to do is we're going to plug that x into the other equation. So it's going to be 3 times negative 2y plus 2 plus 4y is equal to negative 4. And notice we plugged in x into this x. All right? So now when you solve this equation, you're going to get negative 6y plus 6 plus 4y is equal to negative 4. Negative 6y and 4y is negative 2y plus 6 is equal to negative 4. Subtract 6 from both sides. Negative 2y is equal to negative 10. You divide by negative 2 on both sides, and you get y is equal to 5. So then 5 would be here. In order to solve for x, what we're going to do is we're going to plug that 5 into y of the equation that we solved for x. So now we're going to have x is equal to negative 2 times 5 plus 2. So x is equal to negative 10 plus 2. So x is equal to negative 8. So then there is our final answer. X is negative 8, y is 5. If we have to write this as a point, we would say negative 8, comma 5. All right, so that's solving by substitution. You get a variable set by itself. You plug that variable in, to the other equation, solve for one of the variables, and then you have to plug back in again. All right, method number 3, we're talking about elimination. So elimination is where we're going to try to get rid of a variable. So this way can be a little bit tricky, but some people really enjoy this way as well. So what I see here is what we want to try to do is we either want to try to eliminate the x's out of the equation or the y's out of the equation by adding the two equations together. In order to do this, we're going to have to usually manipulate the equation. In this case, I find it easier to eliminate x's, and that's because if I would multiply the top equation by -2, that would give us negative 4x plus 8y is equal to negative 26. And so now, if I add these two equations, what's going to happen is 4x minus 4x is going to cancel. Negative 5y plus 8y is going to give us positive 3y. 8 and negative 26 is going to give us negative 18. Now we have 3y is equal to negative 18. We can divide by 3, and you get y is equal to negative 6. In order to solve for the rest of this problem, you just plug negative 6 into whichever one of the equations you want. So I'm going to plug negative 6 in right here. That's going to give us 2x minus 4 times negative 6 is equal to 13. So that's 2x plus 24 is equal to 13. So subtract 24 from both sides. You get 2x is equal to, what is that? 13 and 24, the difference would be 11, so negative 11. Divide by 2 on both sides, and you get x is equal to negative 11 halves. So then our solution for this is negative 11 halves and negative 6, or negative 11 halves, comma, negative 6, depending on how you're writing your solutions. All right, so I want you guys to try number 7 for homework. So you're going to try both the elimination method and the substitution method. And I'm going to come down here to number 8, a word problem. So the hardest part about the word problems is physically just setting these up. So for number 8, it says your family is planning a 7-day trip to Florida. You estimate that it will cost $275 per day in Tampa and $400 per day in Orlando. Your total budget for the 7 days is $2,300. How many days should you spend at each location? Hint, you need an equation for the money spent and then a separate equation for the days. All right, so with that hint, that makes this a little bit easier. But without the hint, what you're looking at is you have days on a trip and then you have a cost. Okay, so the days should tell you you need an equation for days. The cost should tell you that you need an equation for cost. So I'm going to call my x's days spent in Tampa. And then I'm going to call my y's days spent in Orlando. It's super important to label these variables because it's going to help you. So then my first equation for the total numbers of days is I'm going to say x and then plus y has to equal 7 because 7 days is the total number of days on the trip. And then we also have it costs $275 every day we're at Tampa. And we're going to add that to $400 for every day we spend at Orlando. And then that is going to be equal to our total budget of $2,300. From here, you have options for solving this problem. What I'm kind of leaning towards is, what am I leaning towards? Maybe elimination, because elimination looks pretty easy in this sense. So I'm going to go, what I would start this equation with is I'm going to multiply by negative 275. So then we have negative 275x minus 275y is equal to 7 times 275 is negative 1,925. What this does is it now eliminates the two x's, So then we have 400 minus 275, which gives us 125. So we have 125y is equal to 2300 minus 1925 is 375. You divide 125 on both sides, and you get y is equal to 3. All right, so this tells us that we would spend 3 days in Orlando. And then we can plug this 3 back into the easiest equation, which x plus y equals 7 is probably the easiest. So then we have x plus 3 is equal to 7. So we subtract 3 from both sides. You get x is equal to positive 4. So then when we're writing the solution to this problem, you would want to say you're going to spend 4 days in Tampa and 3 days in Orlando. And then that would be your solution. All right. I want you guys to try number 9 as homework. But yeah, these are the notes for the first day. As always, if you have any questions, just message me on Canvas, ask me in class. Any of the following works. All right. Have a great day, guys. I will talk to you later.